This video is part 2 in our two-part series describing position, velocity, and acceleration functions, and how we can use that information to describe how a motion is moving through space relative to time. So let's do some examples where we use the information provided in that last video. Given an object's position function in meters, it's changing position in meters as time is going by in seconds. Let's answer a bunch of questions here. We can find the object's position, velocity, and acceleration at any given time. And for example, we'll do it at the end of 4 seconds. So if I want to find the position of this object at the end of 4 seconds, I can plug 4 into my position function. If I evaluate my position function at 4, I get a result of 484 meters. So we are 484 meters away from our initial starting position. To find its velocity at the end of 4 seconds, we could derive the position function and then evaluate it at 4. In doing so, we get 33. And since velocity is describing the rate at which our position is changing relative to time, our units are in meters per second. We are changing 33 meters every second at the end of 4 seconds. To find its acceleration, we would derive the velocity function or find the second derivative of the position function. And when we do that and evaluate it using 4, we can find our acceleration at the end of 4 seconds. So in doing so, we get a result of negative 36. And since we are accelerating or changing our velocity, then we are finding how many meters per second we're changing every second. So we describe that as meters per second squared or meters per second per second. So because our acceleration is negative and our velocity was positive, this object must be slowing down at the end of 4 seconds. We'll answer some similar questions about that coming up. Let's describe when our object was moving left or moving right. To do that, we're looking for the sign of our velocity function. If our velocity function value is negative, we were moving to the left. If our velocity function value was positive, we must be moving to the right. So in order to do that, we're going to find zeros of our velocity function. We're going to find where our object was at rest, and then set up some intervals around that to figure out whether it was moving to the left or right before and after it came to rest. So first, let's find the zeros of our velocity function. In order to do that, we're going to factor, take a 3 out and simplify that quadratic, and then factor the quadratic by finding factors of positive 75 that add up to negative 20. And then we'll find the zeros of that factored form and find out that our object was at rest at the end of 5 seconds and at the end of 15 seconds. So let's set up intervals around those resting points. So an interval from 0 to 5, between 5 and 15, and then after 15. Let's test some values on those intervals using our velocity function. So testing a value in between 0 and 5, like 1, gives me a positive value. If I plug 1 in here, I get a positive value. So if I have a positive velocity, that tells me that I'm moving to the right. Let's test our intervals between 5 and 15. So test a value like 6 and plug it into our velocity function. So plugging 6 in here gives us a negative value. So a negative velocity value tells us we're moving to the left. And then lastly, let's test a value on this interval greater than 15, so a value like 16. If I plug that into our velocity function, we get a positive value. So again, that's telling me that I'm moving to the right on that interval. So we could summarize the information. Our object is moving to the right on the intervals between 0 and 5 seconds and after 15 seconds. And our object was moving to the left in between 5 and 15 seconds. Based on that information, we can actually answer a few more questions about the behavior of this object. So when did the object change direction? Well, the object changed direction when our velocity changed signs. So because we changed from a positive to a negative velocity value, we must have changed directions after 5 seconds. And then again, we were going to the left, or a negative velocity value, and then we changed to going right, or a positive velocity value, at the end of 15 seconds. So we changed directions after 5 seconds and 15 seconds. Our object came to rest right at the moment that it changed directions. It must have stopped before it changed directions. So our object was at rest at zeros of our velocity function at the end of 5 seconds and at the end of 15 seconds. What else can we analyze? We can talk about where our acceleration was 0. And we can do that by finding zeros of our acceleration function. So let's rewrite our acceleration function and find zeros of it by factoring. We can factor a 6 out and find a 0 of this function at positive 10. So at the end of 10 seconds, our object stopped accelerating. We can use that information to determine when our velocity was increasing or decreasing. So if our velocity is increasing or decreasing, we are accelerating in a given direction. If our acceleration is negative, then we would be decreasing our velocity. And if our acceleration was positive, we must have been increasing our velocity. So since we found our zeros of our acceleration function to be at 10, we can set up intervals around that value and then test values on those intervals using our acceleration function. So if I test a value in between 0 and 10 and plug it into my acceleration function, I get a negative value. So that means that my velocity was decreasing. If I test a value greater than 10, like 11, and plug it into my acceleration function, I get a positive value. So that means that my velocity was increasing on that interval. So we can summarize that information and we could answer some more questions. Let's put a bunch of stuff together here. Let's talk about where our object is slowing down and speeding up. So in that last video, we said that if our velocity and acceleration functions have the same sign, they're working together, meaning that our object is speeding up in that direction. If our velocity and acceleration functions have different or opposite signs, that means they're working against each other, meaning that our object is slowing down. So we combine all of our intervals from our velocity and acceleration functions. Our velocity intervals were 0 to 5, 5 to 15, and 15 onward. And our acceleration intervals were 0 to 10. So if I could just combine all of those intervals, then I get intervals from 0 to 5, 5 to 10, 10 to 15, and 15 onward. We could also just replicate the information that we already came up with. We knew our velocity was positive from 0 to 5 and negative from 5 to 15, and then positive from 15 onward. We knew that our acceleration was negative from 0 to 10 and positive from 10 to 15. And so now we can just combine our velocity and acceleration values or signs. If they're opposite signs, we know our object is slowing down. If they're the same sign, regardless of whether they're both negative or both positive, our object was speeding up. And so we can summarize that information. The object was speeding up between 5 and 10 seconds and from 15 seconds onward. And the object was slowing down on the intervals between 0 and 5 seconds and between 10 and 15 seconds.